Hey everybody, welcome to yet another lecture. Here I'm going to talk about void pointers. And if you thought pointers were already abstract, well, void pointers make things a little bit wilder. So I'm going to start by creating a file called point to void dot c. And here I have, just as an example, a structure, right? This is just designed to be an arbitrary structure. It's called bleh. It has a double, an int, and a character. I mean, and I just chose these just so that way it has something. There's really no importance to this. The important part here is that it's just a structure. And typically, well, in main, let's go about creating some data types. So let's go with int, we'll call it A, float, we'll call it B, double, we'll call C, character, we'll call D, and our struct, bleh, we will call E. Why don't we give them some values? We'll give A 1 very cleverly, 2.0. Let's go with 0.03, and this will be just the letter C. Bleh. We'll give it some arbitrary values, a double, so 9.72, an int, 5, and then lastly a character, I will say Q. Right, so these are typically, this is the 5 data types that you'll see in a C program. Of course, on line 14, struct bleh, it will vary. If you deal with various structs, you can make them real crazy, as you can customize how they are. But typically, you'll see an int, a float, double, char, or a struct in your C programs. Now, so if I wanted to make a pointer that could point to each one of these, I'd have to say I'd need something like this. We'll have the associated pointers point to the associated variables, right? So A pointer can point to A, B pointer can point to B, and so on. So what if we could have something that's a little bit more abstract? Say something like this, a void pointer. Now, probably before just now, when you see void, it's usually with a function. And if you have void before a function, it means that you're returning nothing. So what does void pointer mean here? It points to nothing? Does it just point to nothing? Well, what's pretty sweet about void pointers is that you can not point them to nothing, but you can point them to everything. And here I have it pointing to an integer, then a float, then a double, then a character, then a structure. So normally, I could not do this with any other type of pointer. Right? A pointer to an integer can only point to an integer. So having a void pointer being able to point to an integer, then a floating point value, would seem unheard of. This doesn't make sense for a strongly typed language like C. However, if I save and quit, and then I type gcc point to void, there's no errors. There's no segmentation fault. Our program was able to run without errors. Let's make this program a little bit more verbose. So now, when I have my void pointer point to a variable, we're going to print, hey, I just pointed to this data type. So let's run this program again. No errors, right? So the void pointer is able to point to any one of these data types. So that's pretty neat. Well, since we have a void pointer that can point to these data types, well, what can we do to access the data that's here? Well, here's how I would go about dereferencing it. So things just got a little bit interesting. So let's take a look. Here, since our void pointer points to an integer, when I dereference it, I need to cast the variable as an integer, as a pointer to an integer, as a dereference the pointer, right? And now, since our void pointer points to a float, I need to cast the dereference as a pointer to a float, right? And the dereferencing of a void pointer is kind of a, you need to keep an active track of what the data type you're pointing to is, right? Because when it dereferences, when a void pointer is dereferencing, it doesn't know what it's dereferencing. There's a difference between dereferencing an integer and dereferencing a float and dereferencing a double. For example, we know that integers, well, on a 64-bit operating system, which you guys most likely have, is 4 bits. When we compare it to a double is 8 bits. So dereferencing 4 bits and dereferencing 8 bits can make a real big difference. Characters are only 1 bit. So the difference in dereferencing a character and an integer is also big. And don't be fooled, even though floating points and integers are both 4 bytes, sorry, not bits, all of these should be bytes. So even though integer and float should not be, since they are 4 bytes, they are dereferenced differently. So it's very important, so when you're using void pointers, to dereference the void pointer as such. You will make it more explicit, meaning doing a cast. Right, and this is a pretty big drawback of void pointers. As they can point to anything, but when it comes to dereferencing, we don't know what we're going to be dereferencing, so we need to do a cast. And, well, when we get to structures, it's quite nasty. First, we got to do a casting. We need to cast the pointer as a struct ble pointer, and then it's dereferenced. Once that entire thing is dereferenced, then we can access x. And we got to do the same thing. We got to cast our void pointer as a struct underscore ble pointer. Then that lets us dereference it. Once this is all dereferenced, we can access y. And rinse and repeat this painful process for z. So what is even the utility of using a void pointer? Well, it lets us get even more abstract, and this is pretty much a gateway used to learn about for learning about dynamic memory allocation, using functions like malloc, calloc, realloc, and free, because those functions return a void pointer, and all they do is that they grab memory. And when it's a good practices when using malloc to cast that void pointer that you're returning into the data type you want to allocate memory for. But that's something that we're going to be saving for our next lecture. See you there.